Here we're looking at finding the equation of a tangent and a normal. So let's start off with a tangent first of all. And something that's really important to remember here is the gradient of the tangent for the given point is the same as the curve. So at the point where the tangent touches the curve, the gradients are the same. In example 1, we're asked to find the equation of the tangent. Now remember, the tangent is just a straight line that touches the curve. And it's touching the curve y equal to 2x cubed plus x squared at the point x equal to 1. So I've drawn the curve here of 2x cubed plus x squared. When x is equal to 1, it's around about there. I mean, this is just approximate. Okay, and so therefore, that is our tangent line at that point. So what do we know? We know that x is equal to 1 there. Now if we substituted 1 into this equation, we'd get y is equal to 2 times 1, which is 2, plus 1, which is 3. So at the coordinate 1, 3, the tangent touches the curve, and at that particular point, the gradients are the same. So let's find the gradient of the curve first of all. So the gradient of the curve, we know the curve is 2x cubed plus x squared. So the gradient of that would be d dx of 2x cubed plus x squared, which is 6x squared plus 2x. And we know that the gradient of the curve is the same as the tangent at x equal to 1. So at x equal to 1, we get 6 times 1 squared plus 2 times 1, which is 6 plus 2 is 8. This means that at the point x equal to 1, the gradient of the curve is 8. It also means that that is the gradient of the tangent at x equal to 1. Now our tangent is a straight line and it takes this format, which is pretty much the same thing as saying y equal to mx plus c. So straight away we know the gradient of that line is going to be 8 because we've just worked that out. So what we now have for the tangent, y is equal to 8x plus c. Now how do we go about finding that c value? Well, let's come back over to what we found over here. And we found that when x was equal to 1, y is equal to 3. Now that is a point that the tangent is going through. So that is what I'm going to use. Okay, the point 1 and 3. So it gives me 3 is equal to 8 times 1 plus c. So 3 take away 8 is equal to -5. And so therefore the equation of my tangent will be y equal to 8x minus 5. That is the final answer for that question. Looking at the normal here, we know, or we should know, that the normal is perpendicular to the tangent. And this is really important. The normal to a curve at a point on the curve is the line which passes through the point and is perpendicular to the tangent at that point. So what we should know about perpendicular lines from previous studies in Year 9 and Year 10 is that they are the negative inverse of each other. So if you have the gradient of one, then the gradient of the other will be the negative inverse. Let's put that into action for this next question. Find the equation of the normal to the curve with equation y equal to x cubed minus 3x squared at the point 1, -2. A quick sketch of the graph looks like this. It's a cubic, and what we're asked to find is the normal at the point when x is equal to 1. Now x is equal to 1 around about there. And we know at that point that y is equal to -2. So we're finding the normal. Now if we were to draw the tangent, it would touch the graph at that particular point. But we're not even asked to draw or even find the equation of the tangent. We're asked to find the equation of the normal. And we know that the normal is perpendicular to the tangent at that point. And of course, perpendicular means the normal and the tangent intersect at 90 degrees. So this one here is my normal. So I'm going to start off exactly the same way as I did last time. I know that the curve, the gradient of the curve, is the same as the gradient of the tangent at x equal to 1. And so once I work out what the gradient of that tangent is, I'm then just going to flip it and make it negative. So the gradient of the curve is d dx of x cubed minus 3x squared. And of course, d dx of that, when I differentiate, 3x squared minus 3 times 2 is 6x. Now, the gradient of the curve is 3x squared minus 6x at the point x equal to 1. So at x equal to 1, we get 3 times 1 squared minus 6 times 1. And that equals 3 take away 6, which is a negative 3. Now that's the gradient of the curve at x equal to 1. It's also equal to the gradient of the tangent at x equal to 1. We wanted the gradient of the normal. So the gradient of the normal, we know, is equal to minus 1 over the gradient of the tangent. So if the gradient of the tangent is negative 3, we've got negative 1 over negative 3, which becomes a positive 3. And so therefore, because we know the normal is a straight line and takes the form y equals mx plus c, we already have the gradient of the normal. So y is equal to 1/3 x plus c at the point. Now, what's the point that the normal goes through? It goes through 1, negative 2. So when x is 1, y is negative 2. That's going to help us find our c value. So substituting that in, minus 2 is equal to 1/3 times 1 plus c, which gives us minus 2 is minus 6 on 3. Take away 1/3 gives us minus 7 on 3. And that is my c value. So therefore, what is the equation of my normal? So the equation of the normal, y is equal to, what was the gradient? It was 1/3 x take away 7 on 3. Now that is the final answer we were looking for there. This is for the normal. You can see that our calculator, if this was a technology exam, we could straight away put the information in and get the tangent line and the normal line without having to do all of that working out.